Hey everyone. Yesterday I showed you a demo of the project I'm working on, TagPro-Stats I worked on for my Stackathon project. And today I'm going to talk a bit about the story of creating this project and talk a bit about the tools and some of the blockers that I came across when developing this project. So first I'll talk about a bit of the backstory of the project. So the project is called TagPro-Stats. And TagPro is just a free multiplayer capture the flag web game. It has a very small but tight-knit community, and most of the content in the community is developed by the players, for the players really. And we have a very, very competitive community. Part of that is just created by the developers, just feeding that competitive itch. For example, we have all these stats on our profile page. We have special holiday events where we can collect these flares that you see on the side, and they're just not important. But during the holiday events, people will compete to see who can collect the most of each flare. So it's really pointless, but it just builds this competitive nature in the community. And another part of that is this rolling 300 leaderboard, where we can see who will have the highest win percentage in their previous 300 games. There's a lot of people competing for that top spot as well. Just more about the competitive nature. We have a lot of leagues in the community. There's a North American League, European League, and an Oceanic League. And each season lasts about 4 or 5 months. And at the beginning of each season, we have a draft where captains will just pick the players that they want to select. And during that draft process, we'll have captains will be analyzing player stats. That's mostly what they base off of for who to draft. So stats play a huge role in that as well. We also have special formulas developed by players in the community. For example, you see in these middle columns, the GASP formula just aggregates certain stats and creates a value that determines that player's skill level, or how much that player brings to his team. So a little bit about the history of TagPro-Stats. It's actually been developed before. It was first originally created by a regular player. And I assume he got the data just from scraping it from the profile pages on the TagPro website. And later it was taken over by a developer, and he pulled data directly from the TagPro database to create this, to get the stats for the site. But as of now, it hasn't updated in several months, really. So a lot of people used this before, but now it's not updating anymore. And I started to work on it because I like to use it as well. And a few days after I started to work on it, there was a post on the TagPro forums. Basically, someone said, hey, this site's not updating anymore, can someone take over? And I just posted yeah, I'm working on it. And so there is definitely some interest in this project. So basically the goal of this app is to try to recreate the functionality of the app. And see if I could just do that using Node and JS. Because the current app is working off PHP, I don't really know much about that, so I wasn't really willing to take over from there. And sort of a personal goal, something I wanted to learn from this project, was to learn how to work with large data sets. Because in our workshops, a lot of our workshops at Full Stack, we just work with very small data sets with dummy data. We don't really worry about how much time it's going to take for stuff to get to the page and render. Working with large data sets, you do have to worry about time and space complexity for that. So the base of the app is built, of course, with Node.js and built on top of Bones, which is the app skeleton. Of course, it's developed by the Full Stack staff. And it really uses the 4 main pieces of the stack that we've learned here at Full Stack: Express, Equalize, React, and Redux. And there's a variety of other libraries mixed in, and I'll touch on some of those. So I really just had the idea, and I just dove headfirst trying to develop the project, and just really tried to face issues one issue at a time as I approach them. So this first issue is that there's not actually a way, there's no API to get all player stats from every account in the game. We can go to their profile page and see their stats from there, but there's no like aggregated data anywhere. Also, the developers of the game, they're pretty open-minded and they're very close to the community, but I don't think they were gonna be willing to just give me full access to the database to manipulate all the stats like this until I at least show them a proof of concept for a demo. So a solution to not having access to the database is just to scrape the player stats from the profile page on the official TagPro site. In this case, we can use axios, like we're all familiar with, but there's probably other data scrapers that you could use here. And that will return just a string of HTML that has all the stats somewhere inside there. So then the next issue is parsing that HTML. Since it's just a string, we want to be able to find certain stats from there. And so, of course, we use jQuery for that. And there's probably several different packages I could use to implement jQuery for this. But I saw a couple sites recommending Cheerio. And personally, I didn't really like using Cheerio. I found it to be kind of like very unintuitive. There's a lot of extra data and stuff going on in Cheerio that I couldn't quite figure out. Yeah, I'm not sure if that was like due to the HTML on the site or just something going on with Cheerio, but I did manage to get it working. So now we have data from a profile page, but we need a list of profile pages to scrape from. So I could just scrape those from the old TagPro-Stats site. And so first I'll be scraping like profile URLs from the the current TagPro-Stats site, and then scraping the data from those profile URLs. So it's a bit of a hacky process. And there's over 100,000 accounts on the site, which were seeded by the developer. And that felt like a bit overwhelming to work with for a small project like this. So I tried to limit it to about 6,000 accounts, which would be players that had at least 300 games played on their account. And I ran into some worries trying to seed the database. I had to do it slowly because Heroku is just not very cooperative. Tries limits how much space or how much memory you can use at once. And I was also worried about possibly accidentally DDoSing one of the TagPro-Stats or TagPro site, just like trying to send too many requests all at once. So now we have data for each account, but now we need a way to compare it. Useless is just to have data for all the accounts. So we need an efficient way to store all that data and parse through it. So I tried to use binary search trees, and I thought that would be helpful later on if I wanted to filter through certain stats to see, like, find all the players who have a stat of at least this number. So I originally tried to save these to just JSON files, but I ran into an issue with Heroku where you can't really save, you can't write files on the Heroku dynos. There's just not really a workaround for that. I tried using Amazon Web Services S3, simple storage service, but it's also pretty tricky to find a way to write a file directly from Node to S3. So I ended up saving all this data in the database, which I don't think is a very ideal solution, but it is working. And another thing about the data is we have aggregated data for each stat, and then there's also data for each individual account. So there is some overlap there, and I'll try to figure out a way to minimize that. So now we have all this data, but of course players are still playing more games, changing their stats. We need a way to regularly update the stats at regular intervals. So I imagine a way to do this is to invoke a function that creates a current date object and compares that to a future date object at a time where you want to update the stats, and then finds the difference between those two times and creates a set timeout for that difference. Or you could just use node schedule, which is, I found it to be pretty easy and to use and reliable. So you can create recurrence rules to call a callback every so often. So this hourly stats update rule will call the callback at the start of every hour. This weekly timeline update rule will call the callback on Sunday at 7:55 p.m. So you can be very specific on when you want that callback to occur. And then you just pass that in with the rule and a callback function, and it's pretty easy to use there. So just to wrap up real quick, a few other concerns I had. URL input cleansing, I touched on that a bit on my presentation yesterday. Just making sure that players are inputting valid account URLs. I wasn't sure if I need to protect against like unauthorized put requests, just players trying to manipulate their own stats on the site. And I think a good way to do that was just pass in a secret that's saved on the process environment and check that in the put request. Also, I found that it's kind of a hassle to update SQLized database model definitions after you already seeded the database. There's a workaround for that. It's just kind of tricky and annoying to do. Things I would do differently for my next project, definitely more comments in my code. There's some like very sketchy looking code in there. I don't know what it does anymore. Definitely more commits. That's something my team struggled in Grace Shopper. And also plan ahead. Just I wanted to get this done for Stackathon, but if I was doing this more seriously, I would plan ahead. And some more features that I'll work on, some data visualization that I touched on yesterday as well. More search queries and filters to do more advanced stat searches. And also add player timeline pages so we can see the change in their stats across different weeks. So, thank you.